This next example is going to be a tiny bit mathy. And this is a sort of like high watermark for the sort of math you'll see in Code in Place. It's going to require a little bit of division, a little bit of subtraction. If it needs a little bit of review, don't worry about it. It seems like a good time to learn those things. Um, but what we're going to try to do is draw a square that's 100 by 100 and draw right in the middle of a canvas. That doesn't sound too hard, but it's going to need a little bit of intentional focus. And we should use variables along the way to combine it with our beautiful graphics program. So, should we make this center square? I say we go for it. So, what I have for us to start out with is a really elegant program that has a big bug in it, but it has a bug that basically every beginner writes at the beginning. So I thought we could make it all together. Uh, this program creates a single rectangle and it wants the rectangle to be right in the middle of the screen. When you create a rectangle, you give it the top left corner, so pixels from the left, pixels from the top, and then the bottom right corner, so the pixels from the left of the right side of the square and the pixels from the top of the bottom bit of the square. And then you say what color it is. And I do this really nice thing. I spend time to create the variables exactly how I want them. Some people want to put this all in one line. I prefer to break it up because then if something goes wrong, it's easier to figure out where. Uh, so what I first do is I say, hey, pal, you want your square in the middle of the screen? Why don't I calculate where the middle of the screen is? So I want to get the middle of the screen in terms of number of pixels from the left and number of pixels from the top. And it's simple. I'm told how wide the canvas is. So the middle of the screen is just the width divided by 2. So if you take the width, which is 400, divide that by 2, then you'll get that the middle of the screen is 200 pixels from the left. And the middle of the screen is also 150 pixels from the top. The screen is 300 pixels high. So the middle should be 200, 150. See if we got that right. And then I'm going to draw my square, and I'm going to use the middle x and middle y as the first two coordinates here. So these two things are just equal to middle x and middle y. And then because I'm told the square should be 100 pixels wide, I'm going to say, okay, you told me where to start. I'll add 100 pixels to that to get your right. You told me where to start from the top, and I'll add 100 pixels to get the bottom. Now, this might take you a little bit of review. You can go run this program as many times as you want. Uh, this seems like a really nice way to calculate it. Everything is pretty clear. It just has a bug. I run the program and we get a 400 by 300 canvas, looking pretty good. But it doesn't seem to be drawing in the middle. Don't forget the replay. You can always go back in time and see what happened. If we go to this point, we see that it calculated middle x and middle y to be 200, 150. That seems good. If it's 400 wide, middle x should be 200 and middle y should be 150 because that's 300 divided by 2. What's gone wrong here? Clearly, when we drew this rectangle, it was too far to the right and too far down. Now, this right x and bottom y, they're calculated based off of the top left corner, and they're always 100 plus the x and 100 plus the y, so they're pretty good. These two lines are pretty innocuous. The problem is over here. When we're saying, hey, left x and top y, those are the first two parameters to create rectangle. And I want you to remember this. Those first two parameters don't give you the middle of the rectangle. They give you the top left corner. And when you realize that, you're like, oh yeah, of course it's not in the middle. I told it to have the top left corner in the middle. I didn't put the square in the middle itself. So the top left corner is in the middle, not the middle of the square. Now, what we could do is we could think about this a little bit. So if the square is 100 by 100, if the top left corner is in the middle, then it's too far to the right and too far down. And we can figure out exactly how far right and how far down it is. How far would we need to move this square left and up so that this dot sits at the center? If we moved it left a bit, this dot would be here. If we moved it up a bit, this dot would be there. Let's try out some values and maybe you'll think of a really nice way to get it exactly to the middle. So I'm going to subtract 20 from both the left x and the top y. So subtracting 20 from the left x will move this 20 pixels to the left because it's 20 pixels closer to the left side. Subtracting 20 from the y will move it 20 pixels up because it'll be 20 pixels closer to the top of the screen. If you run this, watch very closely. It got closer. It's not in the middle yet, but it's definitely closer. And we could do some guess and check, and eventually we might try these numbers. And if we tried these numbers, hey, that looks very good. So the left x is equal to the middle of the screen minus 50, and the top y is equal to the middle of the screen in the y direction minus 50. And that's how you get this point over here. What's so special about 50? I'll point out that it's exactly equal to half the square size. So what I'm saying is, if you move the square size half a square size to the left, so 50 pixels, half of 100 to the left, and half a square size up, then this middle dot will be right in the middle. And I belabored this point just because centering things does come up quite a lot in graphics. So square size divided by 2. That's the fanciest way you've ever seen of writing 50, isn't it? But I want it to be in terms of constants. So I want to shift square size divided by 2. It's the exact same program, but now I'm using square size. And that's great because if I made this a lot bigger, let's say we made it 200, program still works great. If I made this really small, like 20, program still works great because as I change square size, I'm subtracting off the appropriate amount always. It's way better to use the constants than to program something like 10 in here. And then when someone changes the constant, it all breaks. There you have it. These lines of codes are very, very helpful. You might probably use lines like this in your own programs because centering things either horizontally or vertically, it just turned out to be really useful. So let's just go over what I did. I found the middle, and then I calculated my top left corner. And to do that, I took the middle point and I subtract off half a square in both directions. The right and the bottom, I just took the top left corner and I added a full square size in both directions. And then I just went ahead and called create rectangle, and it made a rectangle. You could make one too. So that's 0, 0. That's 400, 300. The middle is 200, 150. And so this top left corner is middle x minus 50 and middle y minus 50, which if you did the math would be 150, 100. And if you actually step through this program, you'll see, we do calculate that the left x, in this case, we wanted this to be, 100. And if this was 100, then left x is 150 and top y is 100, which is exactly what we show here in the slides. There you have it, center square for you to play with.